Today we have our speaker, eminent speaker with us, Professor Mohammad Ayaz Alam. He is the Director of Department of Geology in Universidad de Atacama. He is currently working on environmental issues associated with exposure of arsenic and other toxic metals and metalloids in Atacama region of Chile. He is also involved in hydrogeological study of the region. He was also awarded Chilean nationality in March 2019. Today, he will be delivering a lecture on geotectonics, global geogenic arsenic distribution. Now, before I hand over to our speaker, I would like to say that this Zoom meeting might stop after 40 minutes. So I would like I would like to request everyone to rejoin after 40 minutes if the meeting gets over using the same link. And also I would like to request all the listeners to turn off their microphone because it sometimes creates problem if it's switched on in between the meeting. So I would like to hand over to our speaker for the further proceedings. Thank you.
Thanks, Anvesha. Thanks, Dr. Abhijit, for the invitation. And it's really a great pleasure for me and an honor to be talking with this group. I have been collaborating with Dr. Abhijit Mukherjee since not so long. And we have starting to catch up the speed, and I think we'll be on full throttle in quite some time. Yeah. So this is how I am associated with this particular group, which is really very active. I can see it. And with the amount of work it is doing, with the publications it has. I think I need to share my presentation. So for that I need the permission, I think.
Yes. Sir, are you able to share now?
Now I'm trying to share it now. Okay. So everyone can see my screen, my presentation?
Yes, sir.
Okay. So as Anusha just told, I am right now in Chile as a Chilean citizen. I moved to Chile in 2009, and today exactly I'm completing my 12 years here in Chile. And it has been really, really good for me in terms of the personal achievements and also in terms of career achievements as well. And currently, as Anvisha said, I'm the director of the Department of Geology at the Universidad de Atacama. And we are in Chile, we call it Chile, not Chile, as we all learned in the school also, we spell it like that. Yes. So, as I said just now, I have been collaborating with Dr. Abhijit Mukherjee, Dr. Kusun Bhattacharya, and many other people who are working globally in arsenic. And we are working on different topics, and very soon you will get another publication that will be based on what we are going to see today in the topic. So it will be just like a trailer, or it's like a snippet of what you'll be seeing very soon in terms of another publication with Dr. Mukherjee. So this topic, geotectonics, which is driving the global geogenic arsenic distribution. On this topic, Dr. Mukherjee has worked a lot. So all of you are very much familiar with the role and importance of geotectonics in the distribution of arsenic in different parts of the world. So I will not spend much time on that, but I will focus on some particularities that you can see on this aspect, especially in Chile, in also on some light about some of the variations and some other factors that might be associated with this geotectonics. So to begin with, as I will start where I am present at this moment. So I'm here in Chile, and I am present in this particular city, which is called Copiapó, where this university is located, which is the northern part of the country. And in the same region, we have world's highest active volcano, which you can see here on the screen, Ojos de Salado. And this region in northern Chile has been very well known for the arsenic contamination, and there are lots and lots of works which you might have seen around it. But while I'm working on this topic with Dr. Mukherjee, that will be publishing soon, we can see that although we are associating arsenic with northern Chile, we have to see much in detail what are the exact controlling factors for this, so that we have a better understanding. So I will try to enlighten on that aspect in this particular lecture. So just to give an introduction, because all of you are very much familiar with arsenic and its different effects that it can have on health. So today I will focus much on the sources, which are the geogenic sources, which are the natural sources of arsenic that we have to understand. And of these different sources, in a recent work that is just published, we have identified, for example, 7 different sources here in Latin America. And in this one, we can see that 2 of them are more important, which have been highlighted, which is like volcanic activities, and along with that, the geothermal activities associated with this. And then we have obviously the contamination with metal deposits, different ore deposits that we have, and the related mining and processing activities that we have associated with this. These are the 2 important sources. So when we talk about these 2 important sources, immediately we come to understanding that these 2 are very much related with geotectonics. Their distribution is not random. It is very much controlled by geotectonics. Even other sources, for example, the distribution of coal fields, the hydrocarbon deposits, all these are also in some way related with geotectonics. But today, just to emphasize how important the geotectonics is in the distribution, we will focus on principally the volcanism and geothermal activities. And at the end, I will try to just give a brief on the metal deposits, how they could be like associated with this particular distribution. So as I said also, I will try to focus this topic and the discussion around Chile in particular. Yeah. So when we talk about arsenic, the limit that we consider as recommended, or sometimes it is by law, so it is statutory also. So this limit has been changing through time for different reasons. Sometimes it is just a technical reason that the detection limit of the instruments that were used sometime. So, and also sometimes it depends upon the availability of fresh water, the natural contamination that occurs in different parts of the world. So this value is very much subjective. For example, if you see that this value that is set by WHO or the Environmental Protection Agency of the United States, these are here in Chile also, for example, the limit is just set as like 10 microgram per liter or 0.01 milligram per liter, because in different standards, different recommendations, you'll see the units are changing. So I have just put the same units that occur in those standards or the statutory values in that case. And in India also, the value is 10, but there is a condition there, there is a rider there. So in case there is non-availability of that, the limit goes back to the original limit of 50 microgram per liter or 50 parts per billion in this case. And neighboring Bangladesh maintains the same, the earlier one. What happened in Chile, for example, as you can see the number here, 2005, Chile changed this the value from 50 to 10, and when it changed this one, this change was gradual. This change, when it was given, initially it put a deadline of 10 years that since 2005 till 2015, the limit will be strictly 10 microgram per liter, which is today. And they put a gradual change. For example, within 3 years, that means until 2008, all the different entities were supposed to supply the water at, for example, at this moment, up to 0.03 milligram per liter in that case. But today, as we are in 2021, the limit is for Chile is 10 milligram, 10 microgram per liter or 0.01 milligram per liter. That is standard for Chile. If you see globally, so when we talk about arsenic, its distribution, you can see in this particular map where it talks about the risk associated with it. You can see that it is a global problem, not a problem regional to Bangladesh or West Bengal or some other parts of the world. You can see this distribution, the risk goes globally, and everywhere you can see. Then you see another map, which is by Dr. Abhijit and his group, where you can see this distribution in terms of tectonics. You can see where the arc magma is there, the magmatic arcs are there, and then we have these foreland basins, which are also shown in this map, where you can see this particular distribution. And in this map, there is another interesting source that I already mentioned that is also highlighted, which is like geothermal water. For example, geothermal water is one of the most important source which, on mixing with groundwater, contaminates it, and we can see some numbers which are, you'll be surprised if you have not been into this, which are really interesting to just highlight and consider for this aspect, how important it is. So what happens actually, why this magmatic arc is so important, and why the distribution is not even or globally, even if you see the different risk associated with it. So if you just see in this diagram, the values which are marked in the parentheses, you can see under the brackets. For example, if you go to the continental part, in the values goes quite high, and you can see the values are much higher in this particular section, in the continental part, in the volcanic arc section. If you go to, for example, in Mediterranean ridge, for example, the values are quite low. If you go to primitive mantle, there's a further low. And if you go to the marine sediments, the values are like much higher than that are supposed to be from the oceanic origins. And even in that case, the origin is from the continental side. Yeah, so the sediments that are derived from the continents, they only have these values of arsenic going in at this values of like 14 or more above. So this distribution, and why you can see that here you have the value of like 10 in arc magma. When we see that when it is deposited, the value is increasing. Why? Because it gets concentrated, because it is removed from this arc and then they are deposited and they get concentrated. Yeah, here, so the values, even if they are derived from this, where your values you see is around 10, you have the values going up to 14. In some cases here in the continental basins, you will see the values going up to 20 in that case. So this is why we have to focus, and we have to think that geotectonics is something we have to concentrate when we have to focus on understanding the distribution of arsenic globally. As we just saw in this particular map, which is very much clear how different groundwater bodies that we are marked here in this map, which are well studied. We have information about that. We have in-depth studies on these different aquifers. So you can see that we can say with confidence that geotectonics plays an important role, and also that the distribution is very much around the continental margins, where we have continent on one side, where the sediments are derived, which are rich in arsenic. Okay? But this is not uniform. Even if we say that this setting is of the convergent margin is like this, the values are not the same. Even if you just consider, for example, the Pacific plate, like subduction on either side of it, but the values you see on its the right margin or on its like the western margin is different, very much different than the values which are on its eastern side. Why it is so? That is one has to investigate. One has to think about it. But this difference was highlighted by MIT in their work when they're doing arsenic in Taiwan. For example, if you consider the values which goes up to 75 milligram per liter, not microgram per liter here. So you can see how big the values are there in hydrothermal discharges, for example, in different geothermal manifestations that we have on this margin. Then you have the values which goes up to 6.2 only on this side, where we have like Taiwan, we have like Philippines, New Zealand. So all these areas, you don't have the values which are as high as you see although we expect that the values has to be quite high on either sides. Okay, so what we'll see in the next few slides, so what we can see in Chile in particular, how are the values. For example, this 75 milligram per liter value is for Los Humeros in Mexico. So this is the value. If you go to El Tatio, for example, there are some photos of El Tatio geysers that we have in northern Chile, not very far from here. You can see that it is located at an elevation of more than 4,000 meters. And you see how are the values here. Here in El Tatio, the values goes up to 50 milligram per liter, which is little lesser than that Los Humeros in Mexico, but still it is quite higher than the other. And what it does, there are hundreds of geothermal discharges at El Tatio, which give rise to a river, which is called Salado River. Salado means saline in Spanish. That is why it's called saline river actually, it will translate like that. So it has like sediments have like 11,000 milligram per kilogram of arsenic. And this arsenic from this river goes to the biggest river in Chile, which is called Loa, which passes through population in Antofagasta, and it has been one of the most studied regions in the world about the effect of arsenic. So this is, for example, you can see here the contribution of arsenic is from geothermal. That's why one has to be very, very particular, especially if you are in Chile. The source that we have to consider is geothermal or is volcanism. We have to concentrate on that. For example, at the end of the talk, I will also talk about how is the effect of arsenic, for example, with the metal deposits, the different ore deposits that we have across the Chile, but especially in the northern part. For example, you have to see the tectonics of Chile in that context. If you see this is how the subduction is going historic times. So, and they are also monitored. So they are also like ranked also based on their, for example, the different type of activities that are going on, and they are continuously monitored by the local geological survey here in Chile, which is called Cenogemin. And you can see this gap that is here, like in this particular section. And then we have a volcanic cap for the south. So in this part, you don't have, for example, No volcanoes. The highest volcano that I just mentioned, which is almost at the end of this particular volcanic zone, which is called Central Volcanic Zone. Here you don't see Northern Volcanic Zone because the Chile goes further in Peru and up to other countries in further north. So there you have this Northern Volcanic Zone. That's why you see only Central Volcanic Zone here. Then you have Southern Volcanic Zone, and then you have Austral Volcanic Zone. So these are different volcanic zones. And all of these different zones, you can also see the geothermal manifestations that you have all along here in this particular map, where all these plus signs, they demarcate the different geothermal manifestations. So for example, El Tatio, which is in the northern part that we have seen here, it is not the only one which has such high the values of arsenic. We have other manifestations also, which we'll be reporting in our next publications also. So we have to consider that this is important a factor. And other important factor that we have to focus and that we have to highlight, and I will emphasize on that, is the continental thickness. For example, here you can see some contours which indicate the thickness of the continental crust that we see in different parts. You have, for example, passing through the Bolivian capital of La Paz, where you see the values quite high, and these values goes further increasing and increasing. Why I say that? Because there are some geothermal manifestations which are on the continental part, continental crust, which is quite thicker, and it has really higher values of arsenic. And at the same latitude, if you have some geothermal manifestations which are close to the coast, the Chilean coast actually here. So these geothermal manifestations have lower values of arsenic as compared to this. So if it was only considering the geotectonics or the controlling factor, it will not be sufficient. There is a subduction, and we have a continental margin, so the value will be like so much, so and so. But here, what we have to investigate, what we have to further study, is how is the variation of the thickness of the continental crust in different geotectonic settings. So this is one thing that here we have tried to investigate, and we have come to some conclusions, which are obviously very preliminary at this stage, that the continental thickness is one thing important to consider when we talk about the arsenic concentration. For example, if you see the same thing in a section, so we have, for example, a cordillera. It's like the mountain range that it's a Spanish word, it is used in English as well. So we have like the Western Cordillera and Eastern Cordillera. What is Western and Eastern Cordillera? You see the Andes ranges. We have two parallel ranges of the main principal Andes. So we can see the volcanic front, which has been changing through time. So we can see the different formations that we can see here in Chile. For example, in Chile, if you talk about the geology doesn't go much further down the lane in geological time because of the active continental margin. We don't have the preservation of the geological records, which are very much older, as we can see in India and other parts of the world. So our geology is much shorter in that context. So if you see this here when I am talking about the high values of arsenic, we are finding that one in this particular section. So we have geothermal manifestations even in the border of Chile, actually at the coast at the coastal part, but their U values are very much low. Often it is less than 10, for example, milligram per liter, as you can see in some of the works that are published about the arsenic in Chile, especially in geothermal context. So when we talk about it, there are different factors that we have to consider, not just the elevation, for example, or the continental thickness. For example, other than the presence of the volcanic activity, the thickness of the continent, this region is also called a Puna region. Puna is the region where you have the extreme, for example, the climate, where you have really high evaporation rate. The elevation is quite high, so you have very less air. So even for working in this particular area, it's quite difficult. One has to climatize oneself before working, because working on an elevation more than 4,000 meters is not quite easy, especially for people who are not very accustomed. So what happens actually in this particular region, you have two parts actually, which you just saw here, the Western Cordillera and here the Eastern Cordillera. So in this part, you have the presence of closed basins actually. These closed basins which are located here, which are having high evaporation because of the temperature, and because of there is no exit for these water bodies, these wetlands that we form here in this part. We have high TDS contents, high salinity. So we have the presence of salt flats, and we have these brine deposits that underlie them. And these brines obviously have a lot of lithium, that is another resource that Chile have in terms of these economic values. But for concentrating on arsenic, these deposits, these salt flats also have high concentration of arsenic as well. Yeah. So we don't have to just focus when we talk about high arsenic concentration in this particular section. We have to talk about the elevation. That is another factor that we have to consider. We have to consider the continental thickness in its part, as we just saw in the other map, another diagram that we had. So we did another study at a local level in this particular region, following the track of the Copiapó River. For example, how this distribution is just not affecting the groundwater or geothermal water, how it is even affecting, for example, the surface water also in that context. So we did a reconnaissance along the course of the Copiapó River, that you can see it is just passing through the city of Copiapó, and also the university also is just located at the banks of it. So we did study how the variation of arsenic is there in the course of the river, and as you can see, the different tributaries also it has. So if this is the profile that we can see of the Copiapó Basin. So you can see how the elevation in a very short distance, as you can see within 100 kilometers, you can see how the elevation is changing from more than 2,000 meters to the sea level in that case. So this is another factor that we have to consider, is the elevation where this occurrence is there of arsenic. So we did the sampling all along the river, and this work will be published in the arsenic conference that will be held in Holland, actually in Netherlands. So these are the different sampling points we did all along, and also we did the sampling of some of the tributaries also in the headwaters of the river. So what we find, we see this in table, so we find the high values of arsenic in the headwaters region. We didn't find the values which are more than the permissible limit by WHO and also by Chilean standards, only in this section, if you see here, in terms of elevation. But then again, we saw these values which are more than 10 in one particular section of the river, where there was a contribution of groundwater to this river. So it was like the losing rivers that we say in geomorphology in that context. So in this part, there was a base flow of groundwater that was contributing to the river in that context. So in this part, we have the higher values of arsenic, which again goes down through the dilution. Obviously, we have the lesser values within the limit. So this is another factor. And this, obviously, there are some anthropic contribution also. So we found one spike that was here, which was related to one particular industrial plant. So this is something that we don't present in that table. So this particular value we have is a point source that we can disregard actually, because we are focusing on geogenic contamination. So this trend was quite consistent in both different campaigns that were done in different parts of the year, in different years also. So this consistency we see, and we can just consider the elevation as one of another factor that we should include when we are talking about, for example, the role of geotectonics. So we had some conclusions. We will not go through it because I just mentioned it already. So finally, what I will talk about is how is the distribution, for example, the different ore deposits in Chile, and how is the distribution of, for example, arsenic concentration that we find in different water bodies, whether it is geothermal or surface water, or we find in some groundwater that have been studied. As you can see, the number of sampling points are very less. There should be more a population of the sampling points to have a more clear idea. But if you compare this with the different ore bodies that you will encounter all along the Chile, so you can see different metallogenic belts which are marked here. So you can see that we have this metal deposits all along the Chile, especially in its northern part. As you go further south, there are other types of deposits as well. We have the placer deposits, we have other ore bodies as well. But focusing on the northern Chile, if you see this map, and if you see the other one where you see the concentration of the arsenic that have been reported. So if you see the numbers, which if the red boxes which are there, actually red squares that are there, they show the highest concentrations have been reported. So if you see that and compared to this particular map, we don't see much of the ore bodies in this particular part. What we see is the geothermal manifestations, like El Tatio is present, for example, like the other geothermal manifestations, which also have higher concentration of arsenic. So even if you consider globally as, for example, the ore deposits as one of the sources and their extraction and the extraction processes that go through, we have to consider that the main contribution that we have and main driver for the movement or the redistribution of arsenic is the geothermal waters that we have to recognize, and we have to validate it through more studies that we are undertaking at this particular time actually. So this is what we wanted to discuss with you, and we want to share with you just a starting point for our collaboration, because there is much to do here in Chile in this context, and we can share much information on this particular topic, and much more information that we will be sharing through our future collaborative publication that we will work on. So thank you very much for your patience, for listening to me.